All right, good afternoon. My name is Greg Wadley with CTC and Associates, and I'm the Clear Roads Administrator. We're here for the final webinar for Project 1702, Standard Specifications for Plow Blades with Carbide Inserts. The research team is Eric Mingy and Jeremy Sala from SRF Consulting Group. Before I turn it over to them, I just want to let everyone know that this webinar is being recorded and will be posted on the Clear Roads website at a later date for viewing at your convenience. We will also have everybody on mute today so that there's no background noise. However, if you have any comments or questions, please enter them into the chat box and we will address them at the end of the presentation. I think that's it for housekeeping items. So I'm going to turn it over to Eric and Jeremy from SRF. And as soon as I unmute, it'll be all yours.
Okay, thanks, Greg. I see. I don't hear Jeremy, but I'm going to go ahead and get started here. I'm going to advance my slide. All right, so this is the Carbide Insert project, and just a quick overview of what we're going to cover here with this presentation. I'm going to run through some acknowledgments and the project needs and goals, and the other elements here that you can see on the screen. Basically, we're kind of follow along with how the project unfolded with the different tasks that we undertook, and definitely found some interesting things and came up with some good final specifications here that we're excited to share with everyone. And by the way, great to see the good turnout here, 19 people on the line for this webinar. Maybe with a lot of people working remotely these days, it facilitates some things like that. So that's great to see. All right, moving on to the next slide. Want to thank the project subcommittee that came together for this, especially Cliff and Brian. They are the two project co-champions. Also Clay, Dan, Rhett, and Tom listed here were involved in the subcommittee, and they provide a lot of guidance as we went through the different tasks on the project. Greg with CTC is great at organizing and keeping us all on track. And then I want to also acknowledge the vendors Kennametal and Cooper Blades. And Jeremy will be talking a bit about their role in the project and how it was valuable to get some feedback from the industry themselves on plow blades and the whole world of carbide inserts. So the project need listed here in the first bullet, carbide inserts definitely have been seen to increase the service life of snow plow blades. However, the quality of the blade, of the carbide inside that blade, has been found to vary greatly, and that has resulted in early failures, as has been noted by many winter maintenance agencies around the country. Another need identified for this project was that no common procurement specification was available for these carbide inserts. The National Association of State Procurement Officials, NASPO, does have something that comes close, but is not a comprehensive specification. So the goals of this project were to develop that spec, and that is hoped to result in procuring higher quality inserts, simplifying and streamlining the procurement process itself for all the different states that a lot of them currently have their own approaches, and then ultimately reduce the cost of the carbide coming from the manufacturers. If they're all working towards a single specification, they can prepare something that's common to everyone and not have a bunch of unique approaches out there. And then another goal of the project was to develop a standard set of detailed drawings that illustrate in like an AutoCAD format the insert size itself, and we'll present all of that here in this webinar. So the first thing we conducted was a literature review. We looked at what's been done with other projects, and the main one I want to highlight here is the Clear Roads 701, which was something that I actually worked on along with our Larry Kirchner, our sub-consultant. This project looked at the development of standardized test procedures for carbide insert snowplow wear, and we looked largely at, in a laboratory setting, what kind of test procedures or inspection makes sense as you're looking at these carbide, and things like looking for visible cracks and doing tests such as hardening and density and porosity and grain size. And one of the findings of this project was that carbide insert quality and service life are most affected by manufacturing methods, and a poor manufacturing process is more likely to result in a failure than the actual composition of the carbide itself. So having this background was important and kind of refreshed myself. It had been several years since I'd worked on that previous project, and when we started this one up, we kind of dusted off those findings and we did the literature search to take a look at what had been done more recently, and not a lot was out there. We found 7 different studies, the first one dating back to the year I was born, 1967. Some of these were not quite on the mark. A lot of them looked at the blade configuration, such as underbody plows versus wing plows, and how effective they were for moving ice and snow, and specialty blades. One finding was that uncontrollable environmental conditions have the greatest impact on blades, which makes it difficult to isolate exactly how a carbide insert is functioning when the environmental condition is rough and variable. Also established improved plow performance is done with carbide inserts, even if it's hard to measure with environmental factors. That there is definitely a feeling overall that blade wear is extended with the use of carbide inserts, and therefore there is cost savings involved. And finally, no prior research had been done to develop standard specifications, which is the topic of what we're doing. So existing agency carbide specifications was the next aspect of the project, and we took a look at what was being done out there, and the Clear Road states are very organized and were very effective at passing along their specifications. We got a total of 34 different agencies to provide them. There were 3 states that were not member of Clear Roads that sent them in: New Jersey, New Mexico, and Oklahoma. So those might be candidate states to try and get to join Clear Roads if they're dealing with some ice and snow down there. And then also a couple of counties sent them in. 9 Clear Road states said they're using the NASPO specifications that I had mentioned earlier. And we took a look at, we tabulated all these different specifications across multiple different individual specs, and there's quite a bit of variety in how different states were specifying these categories, but there was also some commonality as well. And then also we found little evidence of any independent testing that was done to verify that the carbide that's being procured actually matched the specification that had been published. And I believe at this point I'm going to pull in Jeremy. Jeremy, can you confirm this is the slide that you're going to be starting from?
Yes, can you hear me okay?
Yeah, I got you.
Okay, so also part of our research was sending out surveys to the Clear Roads members, and we sent out a broad survey with questions ranging from the type of blade you use to familiarity with the previously mentioned Clear Roads project, the frequency of orders, and obviously the testing and certifications that are currently being done. We received 26 surveys back, and we were really happy with that response. What we found is listed in the bullets that you can see on your screen. We found that the majority of the responses claim that they were not aware of any testing being done, let alone getting test results for the carbide inserts. The concern over the carbide quality and lack of testing was consistent with the findings from the previous study. Get the next slide, Eric.
Okay. I hit the button, waiting for it to. I maybe have to do something different here. Hold on. There we go.
Thanks. So we also used that survey to find out which vendors and manufacturers were being most commonly used by agencies. And what we found are the 5 listed on your screen. We sent out a survey to these vendors. Again, the survey was broad. It was questions ranging from number of orders per year to what testing is being performed on inserts before they're shipped. We only received one response on the email survey, so we then had to reach out by telephone, and we were able to receive some valuable input. Next slide, please.
Hold on. Sorry, it seems like the control. There we go.
So some of the key findings we found out from our vendors that we were able to get a hold of are that the trapezoid shape was the most common, but they are seeing an uptick in more bullnose shaped inserts. A lot of them said that with an uncommon blade or carbide insert shape, not common with the trapezoid insert, it can result into long lead times, and that they do see a value with standardizing the specification. They also mentioned that quality and braze width are important to blade life, and that there was concern that because a lot of the agencies do a low bid procurement, that this results in poor quality insert and blades. Instead, what agencies are doing are requiring a certificate of compliance without actually doing any end user testing themselves. And that also at the last bullet point is that quality control is not consistent with the manufacturers. We also brought up the idea of if we included an independent testing requirement in the specification, and a lot of vendors seem to be receptive to that to level the playing field. Next slide, please. Eric, could you go to the next slide, please?
Jeremy, this is Greg. Just to let you know, Eric is offline right now. Do you actually have the presentation?
Oh, it looks like.
Oh, he's moving it around.
Yeah.
I could also.
Okay. It looks like we're back on track here.
Okay.
And it looks like in the, do you want me to address questions as they pop up, Greg, or do you want to wait till the end?
Let's handle those at the end of the webinar, please.
Okay. Okay, so looks like we're back on the slide that we left off on. So in addition to our original scope, a plant visit to the Kennametal plant in Pennsylvania was an added amendment to the project based on one of the requests of one of the vendors. In addition to SRF attending the tour, John Fleming with PennDOT and John Piper, Mr. Pfeiffer with West Virginia DOT was also on the tour. The tour consisted of visiting the manufacturing plant during production, and the second day visiting Kennametal's headquarters, where the tour was more broad and focused on ongoing research and innovations. We felt it was a very valuable experience being able to see the manufacturing process firsthand. Some of the key takeaways we had from the tour pretty much reinforced what we had learned from the initial surveys, that the 25-degree trapezoid shape was most commonly produced by Kennametal, but they were seeing more bullnose, increasing orders. Different agency specifications lead to longer lead times. What they had said was that they could produce multiple carbide insert shapes at once, but as far as producing the full blade, the specifications really had to be the same in order to be efficient with producing those. They also mentioned that the steel mills only produce for snowplow blades once per month, and it was hard to keep material on hand with many different agencies using different steel specifications. And then we had brought up some of the testing we were going to recommend as part of the specification, and they thought that this testing was routine and they handle it in their laboratory routinely. And next slide, Eric, and I think you're taking it from here.
Okay. Jeremy, can you hear me?
Yes.
Okay. Yeah, I don't know if it was my internet connection or something with the GoToMeeting itself. There's a little hiccup there.
Eric, are you on voice over internet right now or telephone?
Okay, moving on to the data synthesis and analysis task. We took a look at combinations. Based on that, we had that as kind of a starting point, and then ran that past our metallurgist who is on our project team. I mentioned earlier that's Larry Kirchner with Kirchner and Associates, and he took a look at that from his perspective, and he identified which carbide properties are optimal, and in many cases they were within the range of what the common specifications were already doing. But he also kind of removed the wheat from the chaff and said, well, this actually doesn't really impact things. We can remove some aspects. And in the next slides, I'll detail what that was exactly. And another thing that Larry brought to the table is a need for testing, which gives power to public agencies to accept or reject blades based on, or inserts based on quality. Larry wasn't able to join us here on the call today, but I did capture a lot of his thinking input, and that's part of what we'll be presenting here. So moving into some specifics then with these standard specifications. Some that could be removed because they're not relevant are there's a loosely defined concept of grade of the carbide, and metallurgist said that was not a meaningful measure. Also, transit structure strength is not a measure that has a bearing. Brazing shear strength as well. Some key specifications to focus on are the composition of the carbide insert, the different percentage of different alloys. I'm hearing some background noise. I don't know, Jeremy,
yes.
Is that coming from you? Okay.
Eric, I'm going to quickly mute everybody, and then I'm going to unmute you and Jeremy again.
Okay. Okay, we're back again. We also included insert dimensions that are common across, that would be a common dimension that all inserts could be made to. And then there are several other properties of the carbide inserts that the specifications cover. Some elements that don't impact performance outside of the carbide itself is the steel that's used in the plow blade. The survey identified 3 different standards of steel, and when we were speaking with Larry about this, he said, yeah, there are differences in these different quality levels of steel, but when you look at how it actually performs in a service condition on the road, they're all fairly comparable to one another. And so we settled on selecting the most commonly used specification, AI-SI 1020, which is used by 55% of the agencies. And we just wanted to put something down so that there could be a standard that people could work towards, but it's not something that's felt to impact the performance of the blades. And similarly with the shape of the insert, trapezoid versus bullnose, as a blade gets used over time, the carbide wears down to whatever angle of contact there is with the pavement, and the initial shape of trapezoid versus bullnose is not felt to have a meaningful impact on the ultimate longevity of the insert itself. Looking at the testing aspect of the discussion, the final report that we're putting together, as well as that's in process, but the task 4 memo that we've issued lays out some best practices for testing. First of all, using a random sampling technique to select carbide inserts for testing, and then require testing be done in an independent lab using standard ASTM test procedures. And I think I saw a comment in the chat box asking about a list of labs, and that's something we could look into, but my understanding is that every major metropolitan area in the country would have metallurgical shops and testing abilities, and these ASTM tests are pretty common and standard, and there should be a local lab throughout the country that can do this kind of testing. Continue to require certification of compliance for some of the specs that can't really be tested in a lab. And also don't be too stringent in interpreting the test results. There are going to be some qualities that are maybe missed or missed by a little bit. And when you look at the bigger picture, maybe that's a good blade and it should be accepted. So there's an AQL process, acceptable quality level, that helps determine, yes, this is acceptable without going by the letter of the law for every single test result. So that helps it kind of be more practically applied. And then the last thing, which is maybe hard for some agencies to do, is to incorporate consequences of missing a test into the purchasing. So that's something to be looked at as a person. Yeah.
I'm sorry, I was just going to say you were cutting out for a little bit there. So if there was something that was not up on the slide you wanted to address, you might have to go back about 20 seconds.
Okay. Yeah, I think I got a note saying that there's a poor connection on my end. Yeah, I guess I kind of just touched on some of what's listed here on this slide. The big thing is this AQL process doesn't have to be, allows you to select some inserts that are maybe have some marginal test results, but in the bigger picture, they're acceptable. Okay, moving on to the next slide here. Okay, so the first category of specification, this is basically like a one-page spec that we developed, and this, I broke it into 3 slides, and I don't think it's worth the time on the phone here to go through all the specifics of what is in the spec. So I'll just kind of touch on some high points here. This first third of the spec deals with the plow blade itself, the steel portion of the blade, and it talks about the dimensions of the blade. A commonly used dimension is 48 inches. However, some states use a 3-foot blade, for example, and so this specification allows different lengths to be provided in 1-foot increments. So we're trying to allow some flexibility for how agencies have procured. Let's say you have a 10-foot blade, you've got 2 4-foot sections, and then I guess 2 3-foot sections and a 4-foot section would make 10. So there's some needs that way. Let's see, the spec also was split into a trapezoid spec and a bullnose shaped spec, and so I've kind of combined them for simplicity in this presentation, but they're basically the same spec with just some differences related to the shape. And I've provided those 2 different shapes here so people can kind of look at what this looks like. On the left is a trapezoid, so this, I guess, is upside down. You would have this flipped 180 degrees for the part that would be touching the pavement, but it's the contact is either made with the trapezoid or the bullnose on the pavement. And I think that's all I need to cover on that slide. The next third of the specification is about the carbide itself. And the first grouping here is about the material composition with the tungsten component, the cobalt, and then 1% maximum allowed for any other elements. So there's some range in percentages here, and if you're within this range, you're going to have a quality carbide itself. Then we identify the different shapes of trapezoid versus bullnose. For the inserts themselves are just a few inches long, or I'm sorry, 1 inch long in length, and then you can see the thickness and height is specified as well, and the radius, the curve shape of the insert. The next set of bullets involve how you define the performance of the carbide. Hardness is one aspect of performance, and the value there can be tested with this ASTM test procedure B29492. Density, expressed as grams per cubic centimeter, can be tested with that other ASTM spec 31108. And then porosity is defined by the grain size in 3 different levels of grain size. I'm sorry, I think I'm saying that correctly. And there's ASTM testing standards that define that porosity and for each of those different thresholds. And then finally, there's a visual inspection of cracks and any laminations that is done to physically look or visually look at the insert itself. So I kind of went through that material kind of quick. I'll maybe pause and see if there's any. A lot of this is kind of the meat of the specification itself, is this slide. So let me just pause and see if there's anything in the chat, or Jeremy, if there's anything you think I should mention or expand on here. And if I don't hear anything, we can just go ahead and capture some of that discussion at the end of the presentation. All right, so I'm going to keep moving on then. The last chunk of the specification deals with brazing. And this was an interesting aspect. We heard from the manufacturers that this was an important element to review. But in talking to our metallurgist, he said that the brazing really isn't that critical. It just needs to hold the carbide insert within the blade, and as long as it's held in there, it doesn't fall out, then it should work and perform fine. So some of the aspects of brazing that we do have in this specification deals with the space between the insert and the metal, the steel of the blade itself. Want to keep that down to 1/100 of an inch, and braze the inserts on all sides, avoid having any voids or shims because of lack of close contact between the insert and the slot. And generically use quality materials, BETH methods, and qualified certified technicians. And then I mentioned the gaps piece before as well. Okay, let me get my cursor back and go next slide. And these next 4 figures show the CAD drawings that we prepared. So this is Appendix A in the report, and this is for a trapezoid insert. So on the left side, you can see there's the hash symbol there is the steel blade itself, and it's 6 inches high by 3/4 inches wide. And the insert there's a slot that's put in the bottom of the blade where the insert goes in, and that slot is 0.375 inches wide and 0.642 inches deep. And the next figure details the insert that goes into that slot. But I just want to give people a bearing as to what they're looking at here. There's a countersunk hole to accept the bolt, so the blade itself can be attached to the mold board of the plow. And the right half of the figure shows a 4-foot and 3-foot blade with the hole spacing for bolting the blade onto the plow. So this is something that can be incorporated into a spec and handed off. The next figure in Appendix A is size of the insert itself. In this case, the trapezoid has a width of 1 inch plus or minus 0.005 of an inch, and the other dimensions here as shown. Appendix B is the same information, and it's time for a bullnose shape. There are some, I guess the only difference on this figure is the slot depth is it's a little bit of a deeper slot to accommodate the size of the insert. Otherwise, the other dimensions on this figure are the same. And then the shape of the bullnose itself. Okay, moving on. The other aspect that's included in the specification are some test procedures. So this is language that would kind of come after you've detailed the carbide needs to have this certain hardness and chemical composition properties, and then this is a testing procedure that's we propose to also have included in the spec. And the first bullet deals with requiring testing, ASTM testing, which I mentioned which specific tests those were before, that be done on a representative sample of each lot of carbide materials. And the next bullet deals with determining acceptance of those test results using the AQL process. And then it goes on to talk about how the department or purchasing agency has an opportunity to review and either accept or reject that carbide material. And if something's rejected, then tests need to be done on a different lot of carbide and resubmitted for consideration. So the intent here with the testing, like I've said before, is to try and put some teeth into what before had often been maybe brushed off or maybe verbally said, yeah, we're in compliance, to say, well, prove it. You know, there's a big impact here on the service life of these blades. If poor quality inserts are used, especially in a low bid environment, you're going to have issues with that performance. And this gives an objective testable method of sampling carbide, testing it, and then rejecting it if it does not meet those expectations. Okay, let me get my cursor back. All right, so in conclusion, the one finding of the project is the quality of the inserts does impact the plow blade service life. And there are several needs that we identified for developing a standard specification. First of all, the existing specs vary greatly, and that impacts the ability of the different agencies to get timely and cost-effective procurement of blades when the specs vary quite a bit. We also found some specifications do not relate to the blade performance and could be ignored. And I mentioned earlier, the blade manufacturers would have to develop multiple products if there isn't a standard specification. So the testing requirements will provide some consistent carbide quality and also give agencies some leverage in accepting or rejecting poor performance in their carbide. And then finally, we developed those two standard specifications that I just reviewed. So I guess that's kind of in a nutshell how the project unfolded and the findings we had. And let's maybe open it up to questions at this point. And Jeremy, if you want to jump in first with anything that you think we want to be sure and share. Otherwise, I think we'll go to the question piece.
I think going into questions is appropriate.
Okay. Right, I've got the project champions up here. Wanted to thank Cliff and Brian again for their involvement. And Greg, if you want to, I guess, unmute and see if there's any questions.
So can you guys hear me right now?
Yeah.
Okay. Well, everybody is actually unmuted, at least from this end, so they're probably got themselves muted, which I appreciate. But there's currently no questions in the chat box, so we will just open it up to anybody who has a question or comment right now. So If so, please unmute yourself and speak up.
Well, this is Scott Luke from Ohio. I did hear a bunch of what you said about the testing as can be done about any major multiple in the lab. What I was curious about though too, the brazing. I recognize you said the brazing wasn't that big of a deal, and I kind of found that odd. Could you elaborate on that? Why they didn't really think it was a big a deal of it breaking down?
Yeah, maybe there's a more nuanced answer there. Let me take a first stab at it, and maybe Jerry might have some other thoughts. But the brazing piece, I remember there was some description of the brazing strength and having to quantify that, and that was maybe the aspect that was not as critical. And it's more important that it be brazed correctly and that there not be gaps and voids in the brazing process, but it be a tight fitting slot and consistent brazing all around. And the strength or performance of the brazing material wasn't as critical. That's kind of what I'm remembering as I think about a more nuanced answer there. Jeremy, do you have anything to add?
I think like you had mentioned, based on our conversations with our metallurgists, is that as long as quality materials were used and a qualified technician doing the brazing properly, it wouldn't have an effect on the service life of the blade itself, is how it was explained to us. Yeah,
and I guess I'd be curious if you've seen anything different when taking blades off of plows and throwing them in the discard pile. Is there missing inserts or something that would suggest they maybe are falling out because of a brazing issue?
That's a good point. Thank you.
All right, any other questions?
I guess I do have another one. If nobody else is there.
Okay.
One of the things that happened, I know, was blades. There was some complaints I heard about how the blades were actually, the carbide was removed to be tested from like existing blades. That using a plasma torch would take away from the integrity of the carbide or something like that. Have you found any consistency with that, or any kind of justification for that at all? Anything you tested?
Yeah, that's a good point, and we didn't touch on that here, but the testing here needs to be done before the inserts are installed in the blades, and so that means kind of backing up far enough in the process of the installation process to get those inserts tested and accepted before they're inserted into a blade. And that, I guess, that could be a challenge depending on the sequence of events and how different manufacturers stock their blades, but that's the recommended application for that test procedure.
Okay, thank you.
Hey, Greg, this is Dave from New Hampshire.
Hi, Dave.
Scott, you mentioned, I think, what I had brought up the other day. So with New Hampshire, we require, considering we are the lowest bid state, and end up with obviously the product that is the cheapest. The company that we're going with lost the patent, and now everyone's starting to copy the patent. And what we noticed is once we started getting blades, they were wearing out very, very quickly. On paper, the company said they met the specs. We put them to use, and where the original blades that we had would sometimes last a couple of years, we're burning through two, 3, 4 sets of these other blades within a year. So we put in our contract that we had to have the certificate of testing that they met. We got that, and then we are cutting our blades. So once they provide that and they get the bid, when they deliver the blades, we're pulling blades out of the pallets, random numbers from random pallets, and that's where the plasma cutting came in that Scott was talking about. Is we're cutting the carbides out of the blades and then having them tested with the final product that's being delivered. And we are seeing that when we send them off for testing, they failed, And the first thing they pointed to was the fact of the way we cut them out and such. And we cut them out differently, and some of them still failed again. So we don't, I hate to say it, but we don't trust necessarily until we get the final product, and we want to cut those open versus trying to do it in the process of assembly, as you were speaking about earlier. Because we feel as though that, yeah, you could go there and pull a carbide out, but that doesn't mean that carbide, that batch is even going to end up in the blades that you end up getting.
Yeah, that's a good question, and it kind of gets into the details of the supply chain and how the industry operates, and if they can be trusted to have that follow through with this test is tracked to this level, to this lot of carbide. It's a bit outside the scope of my understanding of the process, but I guess that's a good point. Does anyone else on the phone have encountered something like that and have an idea of how that could be addressed? One thing that I think of is, we had that discussion with that tour at Kennemental. I wasn't on that tour, but Jeremy was there. And Jeremy, would anything like that come up where they talked about how they have like this, there's a term for it, like ownership of the tracking of materials from their raw source to a final product?
Not on the Kennemetal trip. They did mention that specification of brazing shear strength that was in a lot of people's specifications, and they had stated that that's a hard test to do because you have to destroy the blade essentially as soon as it's complete to test that. And then based on what our findings, brazing shear strength doesn't really relate to the performance of the blade. And then also going through that tour, we asked about some of the QC that they do per lot, and really what we found is that nobody was aware of a formal QC process, but what they did do was check dimensional tolerances as soon as a carbide insert was manufactured.
So you're saying that they checked the dimensions, but didn't actually check the chemical composite of the material?
Not well. What the people I had asked while we were on the tour, they couldn't say that for certain. At that manufacturing plant, that every lot was tested, but I could visually see them as soon as the carbide inserts were produced, checking the dimensions of what they had just produced.
Seems to be an issue here with connectivity.
All right. Any other questions or comments before we wrap this up? All right, hearing none. Thank you, everybody, for joining today. Like I said, this meeting was being recorded. I'll get it posted on the Clear Roads website, and you can view it at some other point in time as well. All right. Thank you, everybody.